This training machine is broken into 6 separate stations surrounding a central servo-controlled dial table. Each station provides a different method of checking the chips for sorting purposes, and therefore offer unique opportunities for training on different sensors and components. Station 0 is the chip destacker station, in which chips are individually pushed from a stack of unsorted chips in order to be loaded onto the dial table. Chips are destacked by a linear air cylinder, then moved to a load position by a variable frequency drive controlled conveyor. Station 1 is the height check station, where the height of the chip in each nest is verified to ensure only a single chip lies within it. This is checked using a frequently used photoelectric sensor by Koops called a Q4X. If multiple chips are located in the nest, as shown here, the Q4X detects the height difference, resulting in a fault message being sent to the machine to notify users. The material check shuttle is located at Station 2, where the material of each chip will be checked for sorting purposes. Some chips have metal cores, while others are completely non-metal, so an inductive prox sensor is utilized to detect this difference in material. The design of this station is overcomplicated for this application, but it mimics an air cylinder shuttle design that is used very often at Koops for different jobs, so it offers another aspect of trainability by getting trainees familiar with a shuttle system like so. Station 3 is the sticker check station, where the chips will be checked for a Koops logo sticker by a vision system. The orientation of the chip is not consistent, so chips will be flipped by a rotary cylinder with a vacuum for suction in order to check the underside of the chip if it does not immediately detect a sticker on the top face. The vision system used is a Cognex IS2000M camera, which is capable of discerning small details like the logos on the chips. Station 4 is the color check station, where the color of each chip will be determined for sorting purposes. Although color sensing is not typical at Koops, this offers a great training opportunity through the handling of analog data from the RGB values. Station 5 is the final station on the training machine. Here, new chips coming from the destacker are loaded onto the dial table by a robot, while chips that have made it all the way around to each station are unloaded and placed in a sorting drawer based on each check they passed or failed. The robot end of arm tool has 2 vacuum cups to pick up the chips from each station, so that multiple chips could be held to minimize the number of robot movements necessary. Upon moving to the sorting drawer, chips are placed based on the checks they passed. Chips that are metal, have a sticker, and are either blue, green, orange, purple, or black are placed in the front 5 stacks as passed chips. Those that fail the color, sticker, or material check are placed in their respective reject bins. The stations on this training machine offer a wide variety of training opportunities for new hires and co-ops at Koops. On the controls engineer side of the project, there are aspects such as the setup and control of machine inputs and outputs, the creation of machine sequences, how to program servos and VFDs, how to use a teach pendant to program an industrial robot, and how to detect fine details through the use of vision systems. On the project engineer side of the project, there are aspects such as how to set up and tune sensors on the machine, how to adjust flow controls and cylinder switches on air cylinders, how to correctly wire up field wearables, and how to perform an I/O check of a machine alongside a controls engineer. All of these opportunities are made possible through this training machine, and to aid in the process, a set of training modules have been designed and documented by the senior project team to help train on these aspects during a week-long training session.
here we have the control cabinet that controls the entire machine, and here we have our programming port where we can plug our laptop in to look at the program, and here we've got our e-stop. In case of emergency, you can hit that button, it will stop the machine, and in order to run again, pull the e-stop out, press the control power button, and you got the power back. Here we have the disconnect for the machine, so you turn that to turn the machine on and off, bring power to the machine, and now we can go inside the panel here. We have our high voltage up top. We have all of our current protection circuits up here with circuit breakers, fuses, sensors, and here we have the drives for the motor. This drives the conveyor right here, and this drives a dial table. And as we move down, we have the 24 volt power supply here to power all of the low voltage DC components with our safety circuits here. So this is the e-stop circuit, and then these go to the light curtains and the gate switches respectively. And here we have our PLC. This is the brain of the entire machine there with the I/O next to it, controlling all the inputs and outputs in the cabinet and on the machine. And we have our Ethernet over here at the end where you can connect your computer and all the Ethernet devices such as the HMI and the I/O link out on the machine. Down here we have a transformer. This machine runs off of 120 volts, a standard wall outlet, and that transforms it up to 240 volts so we can run the robot because the robot is high voltage. That's good. One of the unique challenges that this machine posed us was that the machine has to split in half in order to fit between doorways. So the machine splits here, and we have some electrical connectors down here that you can disconnect the two halves of the electrical for power for the motors. And we also have a connector down here with all the safety, all the wires running through there. So that can be disconnected, and you can pull this right down, and that will disconnect the two halves when the machine is in transport mode, and put it back together. Just a few connectors, and that will make it ready to run again. And we also have our onboard air compressor and a surge tank down there as well to supply all the air for the machine if it is not on the shop floor. If it is on the shop floor, you can convert it over to shop air and it will run off of that.
Our machine's intended function is to train new hires and co-ops. Here, you can see a Koops employee training a new hire on the onboard FANUC robot. The machine was built in a demo mode, yet will be placed in broken states to teach sensors and programming tools commonly used at Koops. The Koops trainer will be tasked with helping the student through the pre-made courses, helping to explain the important functionalities of each component. While the machine is currently only going to be used for new hires and co-ops, a major component of this machine was the functionality to teach higher level courses with new technologies and components.